In chapter 5.5, we introduce two more sets of trig identities. All right. Here we talk about our multiple angle formulas. Remember, when you see the word multiple angle, think multiple of an angle or multiplication of an angle. Here are our double angle formulas, and you might notice that inside of each one of these trig functions, we see 2 times a u. All right, so these are the double angle formulas. The sine of 2u, that can be rewritten as 2 sine u times the cosine of u. The tangent of 2u is equal to 2 tangent u divided by 1 minus tan squared u. The cosine of 2u is equal to cosine squared u minus sine squared u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. Just like our other formulas, the double angle formulas allow us to extend the scope of finding exact values when evaluating trigonometric expressions. And you guys know how much I love exact values. You are not responsible for memorizing these formulas. They will be provided, but it is your responsibility to know how and when to use them. One thing to make note of here, yes, there are 3 different formulas to use for cosine of 2u. So when you're doing problems that involve cosine of 2u, pick the one that seems to make the most sense to you and whichever one you prefer the most. They will all give you the same answers. In some cases, one option might be a little bit better than the other, but I'll leave that to you to figure out. All right, given that the cosine of theta is equal to 5 over 13, and theta is in quadrant 4, find the following. Let's find the sine of 2 theta. Well, we notice that inside of our trig function here, we have a multiple of theta. We have 2 theta, which means we want to use our double angle formulas. We know that the sine of 2u is equal to 2 sine u cosine u, and the only difference here is that, well, instead of u's, we have thetas. So 2 sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. All right, all we have to do is replace those u's with thetas. Well, in order to use this formula, I must know the sine of theta and the cosine of theta. I have the cosine of theta, but we do not have the sine of theta. Fortunately, we have enough information to figure that out. Remember, when in doubt, draw it out. Let's draw out a picture. So the cosine of theta is equal to 5 over 13. Recall that our definition for finding cosine of any angle is the x-coordinate divided by the radius of the arc. We know that this must be in quadrant 4, so we can draw out an angle in quadrant 4. We know that the corresponding x-coordinate has to be 5. We know that the radius of the arc has to be 13. Okay, so here I have my angle theta. Well, in order to find the sine of our angle theta, we're going to have to know the y-coordinate. That requires us to use the Pythagorean theorem. 5 squared plus y squared is equal to 13 squared. This gives us y squared is equal to 144, and y is going to be equal to negative 12. Notice that the y value must be negative because our angle terminates in the 4th quadrant. Right? Y is equal to negative 12. So now we can use the formula. 2 times the sine of theta. Well, the sine of theta is negative 12 over 13. That's y over r, times the cosine of theta, which is 5 over 13. 2 times the sine of theta times the cosine of theta. We can now begin to do out some algebra. 2 times negative 12, well, that's negative 24. Negative 24 times 5, that gives us a negative 120. 13 times 13 in our denominator over 169. Negative 120 over 169 is our answer. Let's now find the tangent of 2 theta. Well, again, we've got a multiple of theta inside of our trig function. Let's use a double angle formula. The tangent of 2u is equal to 2 tan u divided by 1 minus tan squared u. Again, the only difference here is we can replace all of these u's with thetas. Make note that when you see tangent squared theta, or u, either one, that means the quantity of tangent theta squared. So what do we have when we use this formula? We're going to say tangent 2 theta is equal to 2 times the tangent of theta. Tangent is y over x That's 2 times negative 12 over 5 divided by 1 minus negative 12 over 5 squared. 2 times the tangent of theta divided by 1 minus the tangent of theta quantity squared. Remember, tan squared theta, that means tangent of theta squared. And we can begin to do out some algebra, simplifying the numerator and the denominator. This gives us negative 24 over 5 divided by 119 divided by 25. All right, that's a negative 119 over 25. Dividing by a fraction, always easier to think about it as multiplying by the reciprocal. Notice that when I take a negative and divide by a negative, the negatives cancel out. And plugging this into our calculator and simplifying, we get 120 over 119 for our answer. Again, make sure you're comfortable plugging in quantities into your calculator, all right, and utilizing that math frac button of your calculator to turn those decimals into simplified fractions. All right, let's look at another example where we use these double angle formulas. Use the figure to find the exact value of the trigonometric function. Here we are asked to find the cosine of 2 theta. And notice that we are dealing here with a right triangle. Here we have our angle theta in the bottom right-hand corner of our right triangle. Well, when we're talking about right triangles, the acronym that should come right to mind is SOHCAHTOA. Remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So in this case, we want to find the cosine of 2 times the angle theta, a multiple of theta. Well, let's use the double angle formula for cosine. Now, again, there are 3 different formulas that you can choose from. Pick the one that you like the most. I'm going to pick the first one. Cosine 2u is equal to cosine squared u minus sine squared u. So again, remember, in this case, cosine squared u, that's going to be the cosine of theta squared minus the sine of theta quantity squared. As I said, any of the 3 formulas for cosine 2u may be used. Try out the other ones as well. Well, in order to use this formula, we've got to know the cosine of theta. Cosine is adjacent over hypotenuse, which means we're going to have to find the hypotenuse using the Pythagorean theorem. Well, r is equal to the square root of 5 squared plus 2 squared. That gives us r is equal to the square root of 29. That is our hypotenuse of our right triangle. So, using the formula, we have the cosine of theta squared. Cosine is adjacent over hypotenuse. That's 5 over root 29 squared minus the sine of theta squared. Well, sine is opposite over hypotenuse. That's going to be minus 2 over root 29 squared. Now, notice that I did not rationalize either of those fractions. And the reason being is, notice we are going to square each one of them. And when I square a fraction, I square the numerator, I square the denominator. That leaves me with 25 over 29. Let me erase this for you. We'll give you some more room to look here. All right, we've got 25 over 29 minus 4 over 29. Luckily, we've got a common denominator. We can now subtract those 2 fractions. 25 over 29 minus 4 over 29 leaves us with a final answer of 21 over 29. Let's try one more here. Find the cosecant of 2 theta. Now, you might be looking at your double angle formulas. Again, double angle formulas because we have a 2 theta here. Well, there is no double angle formula for cosecant. That being said, we know that cosecant of theta is the reciprocal of sine theta. So we can begin by finding the sine of 2 theta. Let's find the sine of 2 theta and then take the reciprocal of that to give us our answer. Well, to find the sine of 2 theta, we need to use our double angle formula for sine. The sine of 2u is equal to 2 times the sine of u times the cosine of u. That means the sine of 2 theta is going to be 2 times the sine of theta. Sine of theta, again, here's our angle theta. Sine is opposite over hypotenuse. That's going to be 2 times 2 over root 29 times the cosine of theta, 5 over root 29. And again, I did not rationalize either of those quantities. Notice that when we multiply them together, it's going to take care of that on its own. So we multiply, 2 times 2 is 4, times 5 gives us 20, divided by root 29 times root 29, that gives us 29. 20 over 29. This is the sine of 2 theta. Now notice, this is not our final answer. We are looking to find the cosecant of 2 theta, which is just going to be the reciprocal of 20 over 29, because sine is the reciprocal of cosecant. So we take that fraction and we flip it. That lets us know that cosecant of 2 theta is equal to 29 over 20. All right, so there's an introduction to your double angle formulas. In the next video, you'll see how we can use these double angle formulas in solving trig equations.